The first topic we're going to look at in trigonometry are the two types of systems that we use to measure angles, degrees and radians. So in one complete circle, there are 360 degrees if we're working with the degree system. In radians, if I go all the way around a circle, I'll get 2 pi radians measuring those degrees around. So we're going to use those two to set degrees and radians equal to each other. So if we know that there are 360 degrees and 2 pi radians in one circle, means we get the equivalence that 360 degrees is equal to 2 pi radians. And we're going to use that to come up with a conversion factor to change back and forth between degrees and radians. We can get that by dividing either number by the other. So if I want to convert from degrees to radians, the thing that I want to go to is going to be on top of my fraction, and the thing I'm coming from will be on the bottom of my fraction. So I want to go 2 radians from degrees. So radians on top, degrees on bottom. If I put 2 pi radians on top, 360 degrees on the bottom, I can divide away the common factor of 2 and be left with just pi over 180. So I want to go from degrees to radians. I'll use the conversion factor pi over 180. Conversely, if I want to go the other direction, so from radians to degrees, I can use the conversion factor 180 over pi, which I'm getting that from 360 degrees divided by 2 pi radians. So again, I want to go 2 degrees, so the degrees go on top. I'm coming from radians, so the radians go on the bottom. But let's put that into practice, starting up with the top. Converting each of the following angles from degrees to radians. I'll take 100 degrees, multiply that by pi over 180, and I should get the fraction 5 pi over 9. If I want to convert 135 degrees to radians, I'll take that number again, multiply by pi over 180. Oh, I can do this. I have a degree in math or two. 3 pi over 4. I can probably edit that. Once again, we'll look at negative 15 degrees, multiply by pi over 180, and I should get negative pi over 12. Cool. All right, let's look at the reverse, converting from radians to degrees. So this time around, I'll take pi over 4, multiply that by 180 over pi. Those pi's will reduce with one another, meaning I'm just looking at the fraction 180 divided by 4. And that should come out to 45 degrees. If I take 3 pi over 10, multiply that by 180 over pi, and I'll get another number. 3 times 18 is 36 degrees. So not all radian measure angles must include pi. In fact, we'll look at a few angles that don't. So I want to look specifically here at 6. So I'm going to skip ahead a little bit. And if I want to convert 6 radians into degrees, I'm still going to multiply by 180 over pi. But I'm not going to be able to reduce pi in this fraction. So I'm still going to have it there, and it's even going to be in the denominator. So what is that? 6 times 180. That's 36 times 3, 1080. Divided by pi. Cool, and that's in degrees, so we'll be sure to include the degree symbol on that answer. Right, the next thing we're going to want to look at is calculating arc length. So suppose first we should define what an arc is. So if I have a circle and I want to cut a slice out of that circle, like I have over here, looking at that little slice that I've cut out, imagine like a pizza slice, the arc length is going to be this length right there. That is an arc. So the arc is just the piece of the a piece of a circumference of a circle. So it's the rounded edge on a slice. So if we're talking about an arc length, we're talking about the distance or the length of that curved edge, just the distance of that piece of the circumference of a circle. So we have the equation that arc length, S, is equal to r times theta, where S is the arc length, r is the radius, and theta is going to be the angle that subtends that arc, where it's important when we're using this equation that theta be measured in radians. So this is our angle theta right there. And again, it is important that theta must be in radians in order for this to work out. So if we work through a couple of example problems, S is going to be equal to r theta, where in this case, r, the radius is 4, my angle is pi over 3. I end up with 4 pi over 3 as my answer. So 4 pi over 3 inches. The arc length will be measured in the same units as the radius. So we'll keep that consistent. So if theta is already in radians, easy peasy. Now we just multiply our numbers together. If, however, theta is given to us in degrees, we'll first need to convert that angle to radians. So I'm going to start by saying that theta should be 87 times pi over 180. Then we should be able to come up with a number here. Looks like both of those are going to be divisible by 3. So that's 29 pi over 60. So then our arc length should be all of that multiplied together. 10 centimeters times 29 pi over 60, which simplifies to 29 pi over 6. This time we're in centimeters. All right, so this time in the next part of the example, we're given an arc length and an angle and asked to find the radius of that circle. So we can just rearrange that equation. Instead of S equals r theta, I divide both sides by theta to get r by itself. Should have the equation that r is equal to S over theta. So the radius is equal to the arc length divided by the angle, which means that r in our case should be 12 divided by 5 pi over 4, which means that I'm looking at 12 times 4 over 5 pi. Since we call back to algebra, dividing by a fraction is the same as multiplying by its reciprocal. We should come up with our radius as being 48 over 5 pi. And that'll again be in feet, since our radius and our arc length should be measured in the same units. In the next example, we're again going to solve for the radius, but this time our angle is in degrees. So we're going to need to convert that angle to radians. And this time we'll do it in line. So our arc length is 6.5. And our angle should be 117 times pi over 180, which means that this is 6.5 times 180 divided by 117 pi, and we should get a number there. I simplified this and got 10 over pi. So our radius should be 10 over pi meters. Okay, once more with feeling. All right, for the next couple of examples, this time we'll be asked to solve for the angle rather than the arc length or the radius. So in order to do that, we want to use that same equation, but this time we're going to solve it for theta. So we should get that theta is equal to S over R. So the angle that subtends an arc is equal to the length of the arc divided by the radius. So here we have the arc length is 500 miles and the radius is 500 miles, meaning that theta should be 500 divided by 500, comes up with an answer of 1. So we get that our angle theta is just 1 radian. So the angle should not share the unit of the arc length or the radius. So that's not 1 mile, that's just 1 radian. And if we're measuring in radians, we do not need to include units on that answer. So our angle is just 1 radian. Then one more time. This time we're in red. Our angle theta should be 53 centimeters divided by 42 centimeters. And I believe that there's no common factor there. So we're going to be fine to just leave that as 53 divided by 42. All right, problem 4 deals with what we're going to call coterminal angles. So two angles are coterminal to each other if they share the same position. Meaning that so imagine that you're looking in a direction, and if you turn in a full circle, so if you spin a full 360 degrees, you'll be looking in the same direction as when you started. You would consider those two angles to be coterminal. Because if you spin in a full circle or if you turn in a full circle, you're going to be looking exactly the same direction you were when you started. So two coterminal angles are one that we might have one large angle and one relatively small angle, but if we compare their positions, they're looking in the same direction. So we have what we call the unit circle, which we'll get more into in a couple of weeks. But the unit circle looks at just the angles that exist between 0 and 360 degrees, or between 0 and 2 pi if we're working in radians. So I want to find an angle that is coterminal to each of the ones given, but that exists within just one circle. So I don't want to turn in extra circles. If I've turned backwards, I don't particularly want to have that angle either. So I just want to find an angle that's in the same direction as all of the ones listed, but is just within one circle. So nothing extra, nothing backwards. So if I want to find a coterminal angle, I'll take whatever angle I have and add or subtract 360 degrees if I'm in degrees, or add or subtract 2 pi if I'm in radians. So for that first example, I'll take 400 and I will subtract 360 degrees and come up with 40 degrees. Meaning that 40 degrees and 400 degrees are coterminal, so they point in the same direction. 400 degrees is just looking in a direction that's 40 degrees, but spinning in an extra circle. If I look at the one next to that, negative 135 degrees, I'm looking to get an angle that's between 0 and 360, and I'm starting with a negative angle, meaning I should add 360 this time. And I'll end up with a number that looks like 225 degrees. So let's take one more example. I'll look at negative 412 degrees. Again, I'm below a circle, so I'm less than 0. So I'm going to want to add 360 degrees. And I'll get 52 degrees, except that's actually negative 52 degrees. So I've added 360 and I still don't have an angle that's between 0 and 360. So what I'm going to do is just add 360 again. So negative 52 plus 360, and we should get 308 degrees, meaning that the coterminal angle I'm looking for is 308. Let me fix that 8 so that it looks a little better. So what this means is that negative 412 degrees, negative 52 degrees, and 308 degrees are all coterminal to one another, meaning that all three of those angles are going to point in the same direction. But only one of those is between 0 and 360. So if we ever run into a problem where we're looking for a coterminal angle that has to be within one circle, we're just going to keep adding or keep subtracting 360 degrees until we end up inside of that circle that we're after. So in the case of negative 412 degrees, we had to add 360 twice. We'll also see that if we do the example for 1,000 degrees, we'll need to subtract 360 more than once as well. But let's move on to radians. So we're going to look for coterminal angles to radian measure angles now. So same idea. I'm just going to add or subtract a full circle. But this time, that full circle is going to need to be 2 pi radians instead of 360 degrees. So if I were to look at 15 pi over 4, uh, 15 pi over 4 is larger than 2 pi, so I'm going to want to subtract 2 pi from that, which means I'm looking at 15 pi over 4 minus 8 pi over 4, and my result should be 7 pi over 4. So 7 pi over 4 and 15 pi over 4 are coterminal. Let's take a look at 7 pi next. So 7 pi minus 2 pi is 5 pi. But again, that's not quite enough. So I'll take 5 pi minus 2 pi and get 3 pi. Again, I still don't have an angle that's between 0 and 2 pi, so I'll do it one more time. 3 pi minus 2 pi is pi, meaning I know that 7 pi and 5 pi and 3 pi and pi are all coterminal angles. But I wanted the one that's between 0 and 2 pi. Now that's the long way of solving the problem. We could have also simply done 7 pi minus 6. Or nope, that's wrong. 7 pi minus 3 times 2 pi to have just gotten pi. And that would work just as well. So I can either subtract circles one at a time, or I can subtract a large number of circles all at once. Totally up to you. Whichever way makes more sense is fine. Now we'll look at one more example. take negative 5 pi over 6. I'm going to want to add 2 pi this time since I'm below 0. So negative 5 pi over 6 plus 12 pi over 6 is positive 7 pi over 6. So I wind up with negative 5 pi over 6 being coterminal to 7 pi over 6. And finally, we're going to look at supplements and complements. So two angles are supplements to each other, or supplementary angles if I add them up and get 180 degrees. So two angles that add together to get a straight line are supplements. And two angles are complements of each other if they add up to 90 degrees. So if I add two angles together and get a right angle, or two perpendicular lines, that's going to be a set of complementary angles. So to find the complement of an angle, I just want to take 180, take 180, and subtract that angle. So 180 minus 100 should be 80 degrees. I take 180, subtract 135 degrees, I get 45 degrees. Now, if I'm going to look at radians instead of degrees, I'm going to want to use pi instead of 180 degrees, since pi and 180 are coterminal. So we'll take pi and subtract pi over 4, which is 4 pi over 4 minus pi over 4. So 3 pi over 4. And for pi over 3, pi minus pi over 3 is 3 pi over 3 minus pi over 3, or 2 pi over 3. So those are the supplements. Come down here and take a look at complements. So this time, instead of 180 minus the angle, I'll want to use 90 minus that angle. So we'll do 90 minus 80 is 10 degrees. 90 minus 53 is 37 degrees. If I go over to radians, this time I want to be using pi over 2 instead of 90, since pi over 2 radians is equal to 90 degrees, because those are coterminal angles. So I'll want pi over 2 minus pi over 4 to be equal to pi over 4 radians. So pi over 4 is its own complement. And if we look at the complement for pi over 3, that'll be 3 pi over 6 minus 2 pi over 6, which is just pi over 6.